Alright, welcome back, guys. We're going to be looking at section 5E. Okay, so remember we're skipping section 5D. So last class we looked at organizing data, how to organize data using a frequency table, and then furthermore, how to display data graphically using a bar chart, pie chart. If it's quantitative data, we can use a histogram. Okay, and that was important because it allowed the data to tell us a story, or it also allowed the data or trends in the data to be more readily revealed. Okay. All right. So this particular section is kind of a big one, guys, in the sense that it's really important. Okay. We're going to be talking about correlation and causality. Okay, so these two things are often mistaken one for the other. Typically, correlation is mistaken to be causality. Okay, and we're going to talk about why that's the case, and why many times that it's wrong to assume that because two things may be correlated that one's actually causing the other. All right, so let's look at some definitions. So a correlation, and you may have a sense of what this word means outside of a mathematical context, but it says a correlation exists between two variables or two things, okay, when higher values of one variable consistently go with higher or correspond with higher values of another variable, or when higher values of one variable consistently go with lower values of one variable. Okay, so in a sense we have a relationship here, or correspondence. So you have variable 1 and variable 2. Okay, now those variables can represent different things, and we'll look at some examples here in a minute. So if the values of one variable tend to increase, then we may also see a corresponding increase in the values of that second variable. Or, conversely, higher values in one variable may correlate or correspond to lower values in that second variable, or vice versa. Okay? And some examples would be, if we let height be a variable and then weight be a second variable. Okay? There is a correlation between these two variables, height and weight. Okay? And it is that as people tend to get taller, or as their height increases, think about being a kid and growing up. Okay? You're growing in height, but you're also growing in weight, right? Because as you get taller, you're also gaining weight. And so as increases in that first variable, namely height, those correspond to increases in that second variable, namely weight. Okay? Or in other words, the taller people get, they tend to also weigh more, okay, than shorter people. So that's one example. Now that is called a direct correlation. That just means that when we see a change in one variable, it corresponds to that same change in the second variable. Or in other words, if that first variable increases, so too do we see an increase in that second variable. Okay. Now let's look at the second example here. It says there's a correlation between the variables demand for apples, or this could be demand for anything, it doesn't have to be apples, and the second variable, the actual price. Okay, so demand and price. And this is actually an inverse correlation, and we'll see why. It says that is, demand tends to decrease as price increases. So think about this. Think about the price of some new electronic device that you're interested in. Okay, or well, no, let's not do that. Let's think about price of like a commodity. So, you know, food or oil, things of that nature. Oil, which really means gasoline, okay, for most people. As the price of that commodity increases, and people are going to actually demand less, right? Because an increase in price means people are going to have less money to spend because they have a finite amount of money. That's why, whenever, the price of gas goes to $4 a gallon, we try to conserve on our gasoline consumption, right? Or in other words, we could say we are demanding less gasoline, okay? So what we've seen here is that this is an inverse correlation. As the price of apples increases, then the demand for apples will actually decrease because people can't afford to buy as many apples. And then let's look at this last example here. There's a correlation time between practice time, or the time spent practicing, so that could represent our first variable, and skill, the actual level of skill among piano players, or this could be any sort of player of musical instruments. That is, those who practice more tend to be more skilled. We could also use an example in which the first variable is time spent studying for an exam, and then the second variable could be the actual score on that exam. Okay, so the more time you spend practicing, you would expect to see an increase in skill if you're a piano player. Or similarly, the more time you spend studying for an exam, that should correlate with a higher score on that particular exam. Okay, and this would be an example of a direct correlation, or it's also referred to as a positive correlation. Okay, when the variables move in the same way, either they both go up or they both go down, and it's known as an inverse or negative correlation when one goes up and the other one goes down, or basically when the variables move in opposite directions. Okay. All right. So now let's talk about a scatter plot. So a scatter plot is probably something you guys are going to be familiar with if you've ever taken an algebra class. Okay, so a scatter plot involves plotting ordered pairs. And when I say, let's see, where's my cursor here? Okay, you may remember from your algebra classes plotting points, okay, or ordered pairs. You'd have a value for x, and you would have a value for y, and you would find where on that Cartesian coordinate system that point would lie, okay? You would put that point such that its value for x corresponds to the x-axis, and then its value for y corresponds to its height with respect to the y-axis. Okay. Well, very similarly, when we're talking about variables with these correlations, you can think about x as being what we're going to call our independent variable, and then y will typically represent our dependent variable. We'll talk more about this, I believe, when we get to chapter 8. Okay, chapters 8 and 9, where we start talking about functions. But anyway, what you have happening here is you have a value for variable 1, and then you have a value for variable 2, okay? And so you may have a lot of these ordered pairs, and you plot them, and that creates what's called a scatter plot, okay? So a scatter plot consists of a graph in which each point represents the values of two variables. We're going to look at some examples now. Well, before we do that, let's first just kind of reiterate the relationships between two data variables. Okay, so I already mentioned this before. So when you have two variables, it's possible that there's no correlation. There's no relationship between those two variables. Okay, and then you could have what's called a positive correlation or a direct correlation, and that just means that both variables tend to either increase or decrease together. They tend to do the same thing. Think about that example of time spent studying and skill as a piano player, or time spent studying and your performance on an exam, right? The more time you spend studying, the better your performance is going to be on that exam. And then we can have negative correlation. This would occur whenever one variable increases while the other one decreases. And it doesn't matter which one, okay? Variable 1 could decrease, and that could correspond to an increase in variable 2. And the example that we saw in that was prices of apples versus the actual demand. As the price goes up, the demand typically will go down, okay? And then another thing we're going to talk about is the strength of a correlation, okay? The more closely two variables follow this general trend, the stronger the correlation. And in a perfect correlation, all data points would lie on a straight line, okay? But guys, rarely if ever in the real world would you see a perfect correlation, okay? Typically what you do is you go out and you gather this data, and so you have all these ordered pairs, and you plot them, and then you can sort of see a trend, but the trend will typically never be perfectly linear, okay? Or in other words, all those points are never going to tend to make a perfectly straight line. And we're going to see some examples of this. All right, so look at this one right here. This is an example in which we see positive correlation between two variables. You could say the first variable is weight. Hold on just a second, guys. My computer froze. Okay. First, let's look at what we're actually talking about here. So when it says weight, it lists the unit of measure. So this is carats. Okay. So any of you that are familiar with jewelry or precious metals, diamonds are measured in carats, okay? It's just a unit that's used for measuring diamonds, or the mass or weight of a diamond. And so we see that on this horizontal axis, and then what we see on the vertical axis is the actual price. Okay, so the ordered pairs would consist of the weight and it's the corresponding price. Okay, so typically, or evidently, what has happened here is that there has been a handful of diamonds that have been selected, and the weight was measured in carats, and then the corresponding price of that diamond was recorded. Okay, and so we had all that data, and we made this scatter plot. We plotted all these ordered pairs. Okay. So this one right here, for example, this point, this corresponds to a 1 carat diamond that costs about a little over $4,000, okay? And then we've got all this other data plotted here as well. And so what you see is that this scatter plot is trending upward, okay? And so because it is trending upward, this would suggest that as the weight of a diamond increases, so too should we expect an increase in price. Okay, so this is an example of a positive correlation here. These two variables, namely weight and price, are positively correlated. That's the way that you would say that. Because an increase in weight would correspond with an increase in price. And anybody that's bought an engagement ring or a wedding ring or any knows this intuitively, right? It says this is a scatter diagram or scatter plot that shows that higher diamond weights generally correspond to higher prices in those diamonds. Now, there can be other factors that can affect the price of a diamond, the quality, for example, okay? And quality is measured in different ways for diamonds and gemstones, but that's probably also one reason these points don't form a tighter line. You can see they're sort of clustered around this line that I've drawn, but if we were to take out that That's sort of like a confounding variable in a sense, or it's this third variable that we haven't really taken into account would be the quality. If you were to ignore, if you could somehow ignore that variable, then these points would probably form a much tighter line. But anyway, this is an example of two variables that are positively correlated. Okay. Now we're going to look at an example of two variables that are negatively correlated. Okay. So let's look and see what's going on here first of all. So on the horizontal axis, we've got the life expectancy in years. So this would be, the life expectancy in these different countries. And then what we see on the vertical axis is infant mortality. And it tells us how that's defined. It's defined as the number of deaths per 100, or excuse me, the number of deaths per 1,000 live births. Okay. And so you can see this vertical axis is calibrated in multiples of 20. So 20, 40, 60, 80. So this would mean 80 infant deaths out of 1,000. Okay, which is like 8%. And so what we've plotted is basically data from these different countries. Okay, so the corresponding life expectancy in that particular country and the corresponding infant mortality rate. And so I'm going to write this as an ordered pair. So you could think about life expectancy as being our variable 1, or our first variable. Okay. And then that second variable would be the rate of infant mortality. Okay. I know my writing's not great there, but and so how are these two variables correlated? Well, if you look at these points, and each of these points, by the way, represents a different country. So what evidently has happened is, say for example, Bangladesh. And you could look this up. You could look up and see what is the life expectancy in Bangladesh, and then what is the corresponding infant mortality rate in Bangladesh. Okay, and that would give you one ordered pair to plot. And then you would do the same thing for all these other countries. And when you plot them, you can see that there's a downward trend in this data, okay, or in these countries, which this data represents. And what this downward trend represents is that as life expectancy increases, the infant mortality rate is decreasing because these points are falling the further to the right we go. Okay, so this is an inverse correlation, or in other words, a negative correlation. This shows that higher life expectancy generally corresponds to a lower infant mortality rate. And so what's fun to do is kind of think about, well, why? Why is that the case? Okay. Well, because in these countries over here, look at these countries. Israel, the Czech Republic, Greece, Canada, Australia. Also, by the way, the U.S. would be in this area. These are the countries that probably tend to have the best health care in the world. Okay. And in these countries over here, they may tend to have the quality of the health care may not be as great, okay, and so consequently we would expect to see a higher incidence in infant mortality. That's actually what we see. So this trend also goes along with like economics as well, okay, or the wealth of these different countries, okay. A country that has a lot of wealth is typically going to have some of the best hospitals available. Now, whether those hospitals or that top-notch care is available to the populace in large is a completely different consideration. Okay, but anyway, what I want to point out here is that we have a negative correlation. And lastly, look at this. All of these points are downward sloping, but they don't make just a real tight line, okay? But nonetheless, so for example, Russia, for example, doesn't have a great life expectancy. Well, I guess it's got a decent life expectancy, but it's also got a relatively low infant mortality rate. Okay, so evidently maybe healthcare in Russia is a little better than average. And then same thing like right here for Kenya. But up here at Guatemala, Guatemala, it has a decent life expectancy, but its infant mortality rate is actually quite high. Okay, and then you can see these third world countries like Pakistan and Bangladesh, they have really low life expectancies, and they also have really high, relatively high infant mortality rates. All right, well, I'm not going to belabor this anymore. And let me look. Let's see. I think maybe we'll look at one more example. Let's look at this next one right here, okay? This is an interesting one. So this one is talking about the accuracy of weather forecasts. So we've got two different scatter plots, guys, and well, let's read this first. It says the scatter plots below show 2 weeks of data comparing the actual high temperature for the day with the same day forecast. Okay, so that would be this first scatter plot right here. So what we see on the horizontal axis is the actual. It's the forecast of the high temperature done that same day. So think about it this way. You get up in the morning, you're getting your kids ready for school, or you're getting ready for work, or whatever the case may be. You turn on the news, and whatever they're predicting that day, the high temperature to be, that is the same day forecast, okay? And then what we see over here on the vertical axis is the actual high temperature for that day. Now, we wouldn't expect this to be correct, right? But we would expect it to be fairly accurate because it's a forecast being made that very same day. And we do see an upward trend in data, okay? Now, what we have, well, let's keep reading. And a 3-day forecast and the actual recorded high temperatures, okay? So this second scatter plot, what we have on the horizontal axis, is an actual forecast for the high temperature, but it's made 3 days in advance, okay? So this would be similar to, like if today is Thursday, me looking to see what the high temperature forecast is going to be for Sunday. And then what we have on this vertical axis is the actual high temperature for that forecasted day. Now what I want you to notice, there's still an upward trend right here in the data, but look at these data points, guys. They are not as closely clustered around this line, are they, as they are for the same day forecast. And this is because when you're making a forecast 3 days out, you don't have enough information, and consequently you would expect your forecast to not be as accurate. So that's why we see these points kind of jumping around more. There's more uncertainty when you're forecasting or predicting something 3 days out as opposed to predicting something that very day. Okay, so this is an interesting to see this. And you could imagine, what if these high temperature forecasts were done 7 days out? Then there'll still be you'll still see a positive trend, but this data will be spread out much more, okay? So the strength of the correlation will be much weaker. The strength of the correlation here in this first scatter plot is actually quite strong. And then this is weaker still, okay, but it's still a positive correlation. That's why, guys, when you're looking at a weather forecast and you're looking at it 7 days out, there's a lot of room for error there, okay? Now, I will say that meteorologists have gotten a lot better over the years. When I was a kid, they only had 5-day forecasts. That was the maximum. And then they went to 7-day forecasts, and just here recently, a lot are giving 10-day forecasts. Okay, and the reason that they're able to do that with any kind of accuracy is because we have access to more data today than they had, when I was a kid 30 years ago, 30 or 40 years ago. Okay. So, but anyway, let's read this. This really just mirrors what I just said. It says both scatter plots show a general trend in which higher predicted temperatures correspond with higher actual temperatures. That is, both show positive correlations, and we saw that. The points on the left diagram lie more nearly on a straight line, indicating a stronger correlation than in the right diagram, and we noticed that as well, didn't we? This makes sense because we expect weather forecasts to be more accurate on the same day than weathercasts that are made 3 days in advance. Okay. So anyway, I think this is pretty interesting to see. All right, and I think with that, guys, I'm going to cut off this part 1. Okay, and then we're gonna. I think I can fit the rest of this in part 2. So anyway, I'll see you there.